where the faceplate of the cutter head off. And in this particular case, that's what happened. We had to stop and repair that. So we need better, more proven wear detection, more proven inspections and interventions into the mixing chamber in order to this doesn't happen. The system concept we're developing in rock technology is to monitor the cutters in real time. And the data is transmitted via wireless from the cutter face into a PLC, into a computer, where then the operator can see what the condition is of the cutter. This is actually in the operator's control area. We're working on this process for rock technology, but we're also focusing now, because we see it's more important actually in mixed-base technology. We're taking what we know from the rock side and applying it to the soft ground. And what we're actually doing when we're doing this is we're monitoring the speed or the travel distance of the disc. So this works well because we have a pickup in the saddle and a pickup on the cutter itself, so we can actually see if that disc is turning. And from that speed of the disc turning, we can recalculate then as the cutter disc wears, the speed changes. So we can monitor that and know when the disc is wearing. We can also have indications of temperature sensors within the disc cutter itself to tell us if the bearing is failing. It's going to start to get hot. And so what this we can do is if we see the cutters are starting to have issues, we can either do two things. We can stop, have an intervention, or we can, depending on the wear of the cutter, try to take it to a point where we can reduce the face pressure inside the mixing chamber to go ahead and change those cutters, let's say more under a lower face pressure, which then makes it just quicker and easier to change. So take that disc or take that failed bit to the next location in which we can go ahead and change it. This is a picture of a disc cutter, a 19-inch on a hard rock type cutter head. But what instrumentation or what data we're getting from this is the cutter at RPM, the cutter temperature. We're secondary looking at the vibration. We know that in a rock machine, if we start to have issues with these disc cutters, we're going to get a higher cutter head vibration. Also, we're working on in hard rock applications having these sensors last longer. We're having issues with the battery voltage because this is all a wireless system, and the sensors themselves. So working on different techniques to get a higher capacity sensors. But the basic belief being is if we can make this thing last on a rock machine, we should be able to make it last on a soft ground machine. The difference being on a soft ground machine is the discs tend to stop and start turning depending on the geology. So we're working on a way to figure out how to know when the disc is naturally not turning versus when it's actually have a problem because it's not turning. How we measure this RPM is there's a magnet installed in the cutter and in the hub of the cutter. So it's a standard disc cutter with a magnet installed in it. So it's not a special cutter by no means. What is a bit special is the instrument that mounts into the saddle itself. That's this device here. There's a magnet inside the disc itself, but this is the pickup system that's mounted as part of the saddle assembly. This being your bolts and your wedges to take the cutter out. And the time interval between these events is recorded in the operator's cabin, and then from that you can calculate the RPM of each of these disc cutters. And it considers that cutter number 12 is going to turn slower than cutter number 42. That's way on the periphery. That's all pre-programmed into the monitoring device. Brings us to our next poll question. Do you have any upcoming projects that may benefit from the use of a hybrid TBM? Just basically, if you're working on any projects or know of any future projects or see where this type of technology can be used, I think we're seeing more and more of them. At least that's what my straw poll tells me. But I'd like to get your input as well.
Doug, while they're answering that, I have another question. In the next 10 years, do you think hybrid TBMs will become more popular?
Yeah, I see just generally the technical advancements or the projects and the difficulty of these projects is increasing. As there's more and more successes in this mixed phase geology or high pressure geology or squeezing geology or whatever it might be, the tunnel designers are taking more risks. And I don't think risk is a good word, but they're taking an approach where the projects will become more difficult. And we, as the industry of TBM manufacturers and suppliers, as well as the contractors, we've got to benefit from the technology we are getting today and put it into the next advancements in tunneling. And so I see in the next 10 years that in fact we will need a machine that can go from slurry to rock. And the benefits of such a machine are a little bit easier on big diameter being 10, 12, 14 meters, but how to apply that technology back into a Metro 6.5 size. Because I see from the standpoint of the industry, there's Metro jobs out there, many kilometers of Metro tunnels in that 6.5, 6.8 meter range that can benefit from such a technology and reduce the risk of the contractor having serious downtime issues based on geology and the application of the machine to that geology. So as we advance into this mixed phase hybrid type machine and advance it into a smaller diameter, I see that in the next 10 years there will be a big push towards this technology. Another item Robbins is really working on is this atmospheric cutter change technology, in which we can apply to larger machines the ability to change the cutter without the man being under pressure. So he's at atmosphere. He needs to be able to change the cutters without having to go under pressure. And we've worked on this system based on a larger diameter, 15-meter machine, is to have a hyperbaric type device built into the cutter spokes of the machine that allow you to withdraw the disc cutters back into a pressurized chamber in which you can then change the cutter at atmosphere. And so this is Robbins' atmospheric cutter change rack system is developed for that particular purpose, and it eliminates the hyperbaric exposure of the man changing the cutter during the replacement. You don't need to have the certified divers that are typically required during the interventions to change the cutters. You actually have faster disc cutter changes because in typical interventions you need several shifts of preparation before you can even get into the cutter head chamber. And once you do get into the cutter head chamber, you got to do quite a bit of cleaning and inspection before you can physically change the disc cutters. And we want the ability to change from knife edge bits to disc cutters with the same type of under the hyperbaric conditions. The benefits of such a system, I think, we don't even need to speak about it. It's just pretty well known that from such a system we improve the cutter change safety. We have less downtime on the machine, which in effect gives higher performance and penetration rates. It's a simple hand tool operation, not the fellows in the diving suits and under pressure. And then one advantage of the system we're working on is we're looking for a flow-through type design. There are systems out there, but basically they have flow-through. Flow-through meaning the material can flow through the system and not pack up behind the disc cutter, which causes other issues. So we really focused on the system having it conventionally like a normal rock machine or ETB machine, but with the ability to change it from within the spoke. And how this is working, we have a short video, and I would like to play it and kind of explain. So the gray portion is the spoke, and the disc cutter is withdrawn into the spoke. A gate is closed in the front, thus now exposing the cutter, now we close the gate in the front and the back. Now we can then, by opening another gate inside the spoke, we have access to the disc cutter. We've sealed off everything outside. We now have the ability to take the cutter in. It's closed. The back gate is closed. This is that flow-through design I was explaining. A gate inside the chamber is now opened, putting that disc cutter at atmosphere from within inside the spoke. From that point, we can withdraw the disc cutter, change it, inspect it, do whatever we want to fairly quickly by having a series of gates and cutoffs. It's a very expensive system, but if you look at such a system as compared to the intervention time or the downtime, it's a cost advantage, a cost-effective solution to change cutters under pressure. We've looked at this type of a system really on larger machines because physically it takes quite a bit of room. We've been able to apply it on 15 and 16 meter machines. We haven't actually done it. We've done it under laboratory conditions, but not under actual conditions. And engineering is trying to get this type of a system down below a 10 meter machine, which is going to be difficult. I don't think we'll ever get such a system on a 6.5 meter machine. It's going to have to be something quite different than what we have right now. We're kind of running up on our time here, so I thought we would look at the summary of what we've discussed a little bit. And what we're talking about is a hybrid type machine and the benefits in mixed phase geology. We know we have there's some future developments needed in the cutter monitoring, future developments we're working on in the hyperbaric change type disc cutters, wear material, working on different wear materials as far as cutter head wear, cutter mixing chamber wear, and cutter itself wear. Ground consolidation techniques. There's still advantages sometimes to, instead of going under high hyperbaric pressures, is to use grout and pre-excavate, pre-grout the face so I can reduce the pressure in order to actually physically get into my chamber. At times, it's actually less expensive and quicker to do a grout cutoff of the pressure of the water, in this case, instead of trying to go in under heavy pressure. And there's a big advantage, too, to ground conditioning. We're working with the ground conditioning folks to try to develop anti-wear ground conditioning, ability of ground conditioning materials to be used to slow the water down, slow the pressure down, to decrease the pressure, decrease wear in the chamber and the screw. And so there is advantages to this future developments in the ground conditioning. We've kind of gone over the whole machine as Brad did. The current design is what Brad has shown you. It's very effective. It works. But we're looking now to future designs for bigger applications to really try to get away. And a big benefit or big push is cutter monitoring, wear monitoring, and the ability to reduce interventions. Interventions on typical jobs can be a major cost impact if we can reduce the interventions, not only for inspections, but any kind of repair work. And that's what we're looking at in the future of these hybrid type machines. We understand the technology and the basic technology of the machine now, but we're trying to work on improvements of that technology in the case of the cutter head and the changes. So on that, we're going to open up the panel. I think the next step is anybody's questions.
Okay, Doug, so as you mentioned, we're running a little short on time, but we should have enough time for a few questions. There's some that a few people have been asking. The first one, how easy is it to convert between the hybrid TBM modes in the tunnel?
Yeah, on these 12, 13 meter machines and the basic concept Brad had, in which we have a retractable muck ring, hydraulic operated muck ring, the changeover from the speed is quite easy. That can be achieved by we have a two-speed gearbox, one-speed motor. We can convert the cutter head modification from the cutter head drive modification from rock mode to EPB mode fairly quickly. Our goal is to be able to make this changeover in 3 shifts or less. we feel very comfortable we can make a changeover with